Hi guys, in this tutorial we're going to write a cash machine system which is going to be the front end, and it is also going to have its back end, which is the bank system, but we're going to focus on the front end. And this tutorial is oriented at intermediate level students, so you already have a basic idea of Java constructs. You know the keywords, you know how to write classes, methods, and fields, and you're just beginning to understand how to design systems in terms of high-level software design, how to make classes work with each other, and essentially write down specification for such a system. And this is where the tutorial comes in. So we're going to, first of all, have an idea, which I already do, about the cash machine. Then we're going to write it down, which is going to form the specifications for the system. Then create a basic software design, and finally implement it. So far I only have this project and one file, which simply allows me to run and doesn't do anything. That tells me that my IDE is ready. So I'm going to first of all write down the specification for the system. We're going to have, or the bank system is going to have two types of accounts. One is basic, the other is premium. And the difference is that with premium account you can take more money than you have in the account, so you're allowed to take an overdraft. Then each account will have an ID, unique ID, name of the owner, email, and the balance, which is the amount of money that the account has. We can also, so these are the bank sort of back end kind of stuff. Then we also have the front end, which is the cash machine, and it will allow you to enter account ID, then deposit money, so you can either deposit or withdraw, and finally exit. So these are the functions of a cash machine. Should be simple enough at this point. Right, so this is descriptive enough to create a system, but it's also vague enough for students to basically explore what they want to do with this system. Right, so now that we have two accounts, we'll probably do the backend first, which is the bank system, which is going to be a very mock system. It's not going to do much. So first of all, I'm going to create a package called bank, and I'm going to create an account as an abstract class. From here you can already see that there are two accounts, basic and premium. So these are going to be two classes, basic account and premium account, which implies that there is some sort of super type. With supertypes in Java, you essentially have an abstract class or an interface. An interface is used when there is common functionality, but the objects themselves are of different types. So think interface closable, but the objects or the classes could be logger. You can close a logger. And another type could be stream. You can also close a stream. But stream and logger are not the same thing in terms of the type. In our case, both of those things, basic and premium, are type account, so they are actually accounts. So we're going to use an abstract class instead. At this point, we're simply creating basic design for it. When designing a system, you typically focus on the parts that are going to make the final count. So they will be, regardless of what kind of system you end up with. So we are going to have accounts. I don't know what it will look like, but we are going to have accounts. With the rest of the system, you can make the design more flexible, meaning that you can change something on the go and perhaps add something or remove existing stuff. Now that we have two of our accounts, we are going to focus on this thing, which is ID, name, email, and balance. These look like fields that belong to an account. Instead of making them fields, I'm going to create a data structure to store these values. And account data is going to be my data structure. We're going to have an ID, which is going to be just an integer, name, and email. We also have a balance. We're going to make it simple and keep balance as int, which means that you won't be able to have decimal places after the dot. So it's a whole number. In fact, I'm going to make the data structure immutable, which means that you won't be able to change it once you've created it. And I'll let the ID generate first of all constructor, and then the getters. Get ID, name, email, and balance. So we've covered this bit. And since these things belong to the account, I'm going to add account data as a field in the account class. We're going to create constructors so that you can also pass your account data here. Okay, so we can then deposit and withdraw money, and we will probably implement it as part of account. Let's see, public void deposit int amount, which is essentially going to create new account data using the old information, which is that name, email, but the balance is going to be new, so we take account data, get balance, plus the amount that we just added. So this will create new account data, copy these fields, but introduce new value for the amount, which is get balance plus the amount. Then withdraw again, here we're not checking for garbage input. So if amount is less than 0, then you'll get, you're essentially withdrawing. So we won't be checking for that to simplify the design. Withdraw, however, we probably want to check if there's enough amount of money, which will require for us to create another method to check can withdraw. Return account data get balance is greater or equal to amount. In fact, I'm going to remove this from here and create a helper method, which is update balance and new balance, so that we can hide the stuff in there. There we go. Can withdraw. First of all, let's get back to our deposit. Update balance, account data, get balance plus amount. In a similar way, if can withdraw, then update balance but minus amount. And return true. So that the caller knows that we've just withdrawn. Else return false. With deposit, we assume that it can always succeed, so we don't actually return anything. If this gets called, then we know that the balance has been updated. With premium account, if you remember, you can withdraw even if you don't have enough money, but there's going to be an overdraft limit. Let's say private static file, so we'll create a constant which is overdraft limit, which is 100 units of whatever currency we're using, and we're going to override one of the functions or methods, which is can withdraw. Can we do that? Oh, it's private, isn't it? Account, let's make it protected so that we can override it. So that's get account data, get. In fact, we're going to create get balance within the account, just a helper method, which is going to delegate to the get account data. Get balance, just to simplify our code, account data, get balance. In which case we can just do this. That. The more readable your code is, the easier it is to maintain it. So I suggest you create these shortcuts whenever you can. Premium account, get balance. It's private, so I'll make it protected. In fact, let's make it public. Balance plus overdraft limit minus amount. No, greater or equal to amount. Yeah, like this. And this allows us to create a premium account. Right. Let's create the bank object, which is going to be the object that we access our account data from, because we don't want to access account data directly. We're going to create bank object or class, and it's going to store a list of accounts. In fact, we probably need a map, Just going to map an integer, which is the ID of the account, to the account itself. And we are going to add a few accounts just by default. So we won't be able to create new accounts from the cache machine, but we want to be able to actually test it. So we're going to create new accounts here. 1000 is the account ID, new basic account, which takes account data, which is ID, then name, example1, example@gmail.com, and the amount, the balance, which is 500. I'm going to create another one with different ID, say 2000. It's going to be a premium account, and we're just going to change these. It's going to have 200 units of money. So here's our bank. We probably want to access something like account by ID. At this point, you need to think how you want to do it, because the ID could be passed in invalid. So the ID could be invalid. We only have two IDs at the moment, 1000 and 2000. Which means that any integer that is not that is going to be invalid. So how do you deal with these cases? Usually I create a utility class called, it's in fact a data structure called action result. So you try to perform an action. If it succeeds, it returns some kind of data. It may return null as data if the return method would be void, or it returns an error saying if the action fails. So it's like a super-powered optional that you can use in Java 8. Action result. A nice thing about it is you can use this pretty much with any kind of operation that can fail, whether it's input, output, networking, or any other kind of operation. We will add a generic object, generic type T. It's going to have T as data. We're going to have some string, which is error message. So one of these things will be populated regardless of the action. I probably want a few constructors. Action result, T as data, and the other constructor is going to take error message. You could take the error itself, like a throwable kind of interface, or is this an interface? That's us. Regardless, you can take throwable or an exception as instead of error message. Right, this error message. Then we're going to have static factory methods. So they are going to create our action result. Action result of type E this time, which is parameterized success. Take E as data, and we return new action result of that type. Alternatively, we have fail, which is going to take error message. We also want to access the data itself and the error message, and also check is success. If data is present, then we assume that it's success. The operation has been successful. If not, then error message will be populated with the data or with the message that saying why it failed. Now we can easily do stuff like this: action result, account. Actually, no, we don't want to return the account itself. We want to return account data. Get account by ID, int ID, and this is going to be accounts get ID, gives us the account itself. We now want to, let's try that. Account, if account isn't null, that means ID exists in this map. Return action result success, account data. Now account with ID. And we also want one method for each of the functions, which is deposit and withdraw. Deposit is also an action. Int amount. Actually, we also need to take account ID. Or we, instead of doing that, because that is going to call this essentially, because we've already acquired account by ID, and this is now external data, meaning whoever called this has access to that, why don't we use that instead? An account data is created with a valid ID that we're sure of, which means that we can call this without worrying that it may not exist. So account data, get ID. So this will not be null, and we can guarantee that, as long as account data can only be created on our side, which we can kind of do. Can make this package local. There we go. Deposit. We know that this always succeeds, I think. Yes, we know it always succeeds. This, however, can fail. Again, within our context, because there are many things that can go wrong even with this simple method. Where were we? Yes. Return action result success. And since after deposit get account data is updated, we're returning the new account data, which is going to have valid information about the current state of the account. We first need to check if we can deposit. We do withdraw amount. That returns true or false depending on what we've done. true meaning everything is okay. If okay, then we say that it's okay while you're doing this. Else we return fail with the message. Let's say withdraw failed. We might also give the information about the amount. In fact, we also know the amount of money on the account, so we might as well print that. Withdraw failed dot account has account get balance. There we go. That should be enough for the bank. Let's come back to the front end, which is our cash machine. So I'm going to create a cash machine, which is the model of our MVC. It's easier to design the model when you don't have the view or the controller. It's easier to get it right the first time. Considering that in software development many things are difficult to get right the first time. So yeah, cash machine, it will have a bank inside, which we pass with the constructor. Going back to our test brief, cash machine can enter account ID. So these are cash machine responsibilities. Deposit, withdraw, exit. Enter, I'm going to call it login, int ID. And like withdraw, deposit, and amount. We don't need the ID because we are logging in, so we know what the ID is going to be. And we want account data. By default it's null, so we can't do anything with it. Login, call bank to check if it's a valid ID, and then do something with it. Okay, it seems that we need to have some kind of try call kind of structure. So we're going to design one. We're going to create something like try call. We're going to pass a method in here which will be called. If it succeeds, then we continue with second method. If it fails, then we don't do anything, or we handle error if there's one, which means that we need some sort of generic in here, which comes before that. Supplier, because all of our bank operations result in action result object. So this is supplier of action result T. T can be anything. We don't care about the type of that particular data. This is the action. If it succeeds, we then call the consumer, which is the post action. And it's just T because it's interested only in the data, not in the result. So we try calling action, which results in data T, action get, which is action, it's action result T. So this is not data, this is result still. And we also want to check if it succeeded. If result is success, then we do something else. It's failed, we do something else. We catch any exceptions that have occurred. We do something with them, something more meaningful. You could write a handler which will then delegate to some kind of UI object, which would then display something on the screen saying this is the error. But for now, we're just going to print it to the command line. Error get message actually. If it's success, then we have data. Result get data. We pass this data on to this function, which is the one that is interested in the data. Else we have error. If you remember, it's either data or the error message. Just throw a new error, new runtime exception, error message. And this will be caught by this and printed to the screen. And that won't be executed because that needs to know that data is there. So now this becomes try call, and try calling bank get account by ID by passing the ID. Actually, that's supplier, so we need to do this. If it succeeds, then we simply want to assign data to our account data. There we go. Deposit. First of all, let's check if account data is there. If it's not null, then do something. Same with withdraw, and same with exit. Exit is really simple. We're just going to reset it to null. That's it. Deposit. Do we know deposit always succeeds? I think we do. Regardless, let's do the same. Try call bank deposit account data and the amount. With the result, what is the result? Is it account data too? Yeah, data. Well, we didn't do anything, so just ignore it. Actually, we do it something with it because the account data is all the account data, so we have to reset it. In fact, it's the same function. I wonder if we can create some generic consumer. Let's do consumer account data, and it's called update because it is essentially update, and it takes data in and sets account data to data. This is our update, and we simply pass it here. So I'll go over it one more time. This is our helper function. We pass a function or an action that can fail, and we do that. If it fails, then this branch will be executed, and we just bail out. We say there's an error, we can't do what you asked. If it succeeds, then we call the next thing, which is the next action, the next function, which in our case simply update, which is that function that takes the new account data that resulted from this action, and we set it to this one, which is the field that we currently track. so we can do something useful with it, like display the up-to-date information. Withdraw is going to be very similar. Instead of depositing, just withdraw, and this can fail because of this. Right, that should be it, at least for now. We also want to display some kind of info from the cache machine. So let's do toString, and that toString returns account data not null, then account data toString, else nothing, no data. Account data is, oh, we haven't written anything for it. Let's create toString. Account ID, plus new line character, then name, yeah, that should do it. Okay, let's come back further top and create our user interface. So now this is where I'm going to create everything. So we've already done several MVC pattern-based tutorials on this channel. So instead of creating view and the controller separately, I'm just going to push all of them in one class. In this application class, because this particular tutorial is focused on the logic and the model. Let's push everything into a vertical box. So our UI is going to be very simple. That what do we want? We want a field so that we can take account ID and various other things from the user. And we won't be checking for any non-numeric characters, so basically garbage in and garbage out. First of all, put a field there, then a few buttons, submit, or login. Deposit. Draw. And exit. In the same order. And finally, add some text area where we display stuff. Area info. This will probably need to be up top so that we can have a reference to it. Right, submit. What does submit do? The UI stuff should be very simple. So that is essentially our view code, and the set unaction stuff is controller code. We don't have our model access. Cache machine, new cache machine, new blank. I think it takes a blank. Yeah, it does. Cache machine, login. And that will need to access right, we need this. So first of all, take ID from the field, get text, parse it to int, cache machine, login, take this, area info, set text, cache machine to string. Because to string returns all the account data, so when it's updated, if it is updated, then it should be fine. By default it's null, so it's not going to, it's going to say no data. That's set on action for that. Controller for deposit is pretty much do the same, just call it amount. So I'm going to use the same field essentially for everything. Cache machine, what is it, deposit, amount, and then update, button withdraw, take amount, update. It's not login, it's withdraw. Button exit is that. So we don't even need this, we simply exit. But we do need to update so that the new user won't see the details of the old user. Right, let's try this. So this is our text field. This is these are the buttons, and this is, let's separate them a bit. So let's try account number 10, which we don't have. Submit, no data. And in fact, we also see the error, no account with ID 10. These buttons are, well, they're enabled. So once you create new user interface for that, which I recommend you do, because our user interface is essentially just this block of code, you can also bind the disable property of a button so that it's not enabled once we haven't logged in, well, before logging in yet. Account ID 1000 should give us something. Yep, it gives us account ID 1000, balance is 500, so we can now deposit, say 5, balance is now 505, we can withdraw 505, balance is 0, we cannot withdraw further, yes, withdraw failed, account has 0. Cool, let's exit and go to our premium account, which is that, which has a balance of 200 but an overdraft limit of 100, which means we should be able to withdraw 300. Yes, balance is minus 100 now. We shouldn't be able to withdraw further. Yep, we can't do that. Let's add deposit. Balance is now 0, so we've compensated for the overdraft. And deposit further, which is balance. We can exit, we can go back to our original account, which has a balance of 0 because we've done all our transactions. Exit, and that is about it. So that seems to be working. And as an exercise, you could, well, first of all, write a better GUI, definitely. Then add a few things like disabling the buttons or making them invisible until you actually log in to the machine, so things like that. Make an adapter model, which is an observable model from this cache machine, where you can kind of create a bridge between JavaFX and plain Java objects. Right, so in this tutorial we went from an idea, which is a cache machine, to the specification for a system, to then design of that system, and then finally implementation of that system. And we've gone through all the stages. We focused mainly on things like making sure that we don't expose the account itself to the external party. We've done a bit of error handling within the backend and also the front end layer. So this is our first layer of handling various exceptions. This is our second layer. You might want to introduce the third layer, which is the user interface, in which case you will need an observable, some data structure that you can observe real time for changes. And that is it for this tutorial. Hopefully this will help you design systems and link classes together to make them work together as a coherent system. Thanks for watching.